I think biology is such an interesting subject. I just love it when my students get it.
That's a white butterfly, folks.
I'm trying to share the same experience that I have had on a few occasions. And I think there's this moment, and I saw it the other day actually with some of the tutors that work with me in the Action Center. One of the PLAs said there's this spark, there's this something that happens between humans, between brains, when you're trying to explain something complex. And you can see, you've got it, but they don't, and there's this spark that goes off.
What is the difference between simple and stratified in any case?
Stratified has more fluid.
That's right.
And there's that feeling. I think there's this need to communicate, to reproduce that idea in another brain, to share it, to mutate it, to modify it, to make it grow. And there's something there in that love of teaching, I think.
Nothing, see, nothing. Yeah, it's a normal rope. That's fine. That's fine. It's just a normal rope. What? Look at that! What? Look at that! Are you kidding me? I can't. Second try, that's pretty good. But again, it's beating the eye because it's going so fast that thing's flipping over and making a knot.
Perhaps I love my discipline so much because of a few light bulbs that went off in my own head. There were some moments in my life where I was wrestling with a really complex idea and I finally got it. And it just rocked my world. In some ways, it changed me forever.
Bang! Open the sodium channels, close the sodium channels, open the delayed potassium channels to bring the action potential.
I think really one of the most profound images I try to keep as I approach my teaching is not so much me being the center of attention or my students being the center of attention, but biology being the center of attention. I think biology is so interesting, and I really do learn as much as the students do as I go through any class.
We're gonna do the wave because it's the best analogy for how neurons work. Okay, stop. Brilliant. What happened? The wave propagated, but you stayed put. There's even a refractory period. There's a limitation on how fast they can go. Come on, here comes the second one. Look at that. Yes!
Biology is so important. It's so great. It affects all of our lives so much that we're all coming in, learning side by side. But I can share the greatness of biology and hopefully we learn together. That's kind of my icon as I think about the way I teach. Try to make this big class feel psychologically small.
Hold the paper about a foot from our eye. We're going to close one of our eyes.
Well, I think it's really important to empathize with your students. I still get nervous too, I always do. This is actually really easy for me because I was absolutely not the best student. I remember vividly struggling with some of my classes and really not knowing how to study.
Yeah. Oh, okay. Oh, is it? We can say what kind of...
So I started learning how to become an independent learner. And that's what I really wish for every single one of my students. How do you make sense of a complex subject? And if you don't make sense of it, what do? You seek out resources, you go see the professor. But I think to be a good teacher also means that you need to relate to your students and kind of know what they're going through too.
We will test your colleagues with your questions. So the first challenge is to write some good questions for each of them.
The brightest of the bright really get attracted to the university, and I get to immerse myself in these students every single day. I have a class of 400 or so students, and it's a little nerve-wracking sometimes. You never know what they're going to ask, but they really keep you on your toes. And you get to model learning with them. If you don't know the answer, you don't know the answer, so you learn, you figure it out together. And some of these students I've been really fortunate to have in my lab. I think it's really important for students to get hands-on experience, to be engaged with material, to think critically about these concepts. Don't just accept them at face value. Get your hands dirty. Students truly do get to generate their own questions. They think about problems, they read the literature, and then 2 and 2 come together to make 5, and it sparks a new idea, and they develop a hypothesis, they develop a way to test the hypothesis, they develop experiments to do that, they analyze their data, they collect their data.
The humidity from the dry end over to the humid side. And I had a...
They write up their findings, they publish. And they realize that it's messy, it's not real clean, but in the end, this is how information grows. This is where the creative spark comes from. I think I connect with my students because I don't think you can fake it. I think you have to be all in. And you have to really love what you do, and I absolutely love what I do. To me, it's the best job on the planet.
Potassium ions on the inside of your cell.
I think we are really fortunate to have the quality of students we have here at OU.